Oh, what's up? In this video, I explain for you regression algorithms. It's very simple stuff. Here I explain only the mathematics, and when you finish this video here, I recommend to go to the description. There's a link. You click there and go to the GitHub. In the GitHub, I explain how you applicate it with Python, okay? With real data of the Kaggle. I use the price of house, predict price of houses, okay? So here I will explain for you the mathematics. So let's go. So guys, but what is regression? Regression is basically the relationship its data. It's the features and the targets. It's very simple. And we will do functions, and we will optimize these functions. The artificial intelligence is basically this: optimize a function. Okay, we will trace graphs here, do equations, and optimization these equations. Okay, so it's basically this linear regression. We have types of regression. We have linear regression, is like the model. You have the children's too. The children's needs achieve ways for solve specific problems. We have Lasso Regression, Ridge Regression, and the Lasso Nets. The Lasso Nets is the Ridge Regression plus Lasso Regression. I'll explain it for you. I will do here functions, okay? But first of all, I will trace here the types of regression, and yours is specifically functions, okay? First of all, we have the linear. There's the lasso, there's the ridge, and there's the last net. All of this stuff is graphs, and we'll do equation of the line. The equation of the line is basically the angular coefficient plus the linear coefficient. There's no mystery here. This stuff was explained in the high school. Okay, it's very simple stuff. We have graphs here, the graphs of linear, the graphs of lasso, the graph of Ritz, and the graph of elastic nets. The points in the graph is the features, and the line needs to achieve the targets. Okay, I will do blue points. That blue point is the features. The linear regression have normal points. The last regression have a problem, but I'll explain it later. That others have problem. Explain it later. First of all, we have equation of the line, angular coefficient plus linear coefficients. The angular coefficients, here, I will write here for you. Okay, reg equal nxi plus b. The angular and the linear. The equation of the line. And I will do a green line here, okay? With green, like that. You see mistakes here. That line isn't perfect. For take that stuff and achieve the perfect, we'll do a comparison. The subtraction counts, okay? Like that. We have that blue point here. You see it? We will approximate all of that points in the line. Yeah, we will approximate it. For approximate it, we do a quadratic mistake, a cost function. This stuff isn't new. Was invented in a long time ago when Pascal looking for the better for classificate stars in the sky. I think. We have here a comparison. The blue point is y. Okay? I want comparison a lot. I will compare one point only for understand it very well. That's bullet points. Approximation is here, okay? And that black points here of the line is reg. Is the line, okay? Reg. And for all of the blue points, we take all of that informations and drop in a function. That function is a closed function, a quadratic mistake. Okay, we have the indices. The letter n here in the summatory is the indices, is the numbers of blue points. You have the indices here. Okay, we have all of the right points and the y points. It's quadratic. It's basically this. This is a formula, the model formula of linear regression. This stuff is a mistake, okay? For optimize it, we will go back, go back like a parabola. I will draw here a parabola for you. From this stands for minimum of the function and the maximum of the function. Right now, that graph here with that points, we do a aleatory line, and for optimize this line, we will need to go back for the minimum of that function. And for achieve it, we do a gradient descendant, okay? But what is a gradient? Gradient needs to achieve the maximum of the function, and the descendant is like go back, okay? Go back for the minimum of that function here. We do this stuff inside the formula of the line, the angular and the linear. The angular is basically a position, and the linear is an inclination of that line, okay? So angular is a position and inclination of that line here. So right now, guys, we'll take it. The formula is basically the descendant gradient. Yeah, descendant gradient with derivadas, the partial derivative with the derivadas. Okay. But what is a derivative? Derivada was born when Isaac Newton was achieved the value for minimization function. We have derivadas here. The new points, the new angular and the linear coefficients take the old angular and linear coefficients with a line rate of the derivative of the costs behind the derivative of the n behind b, and the angular and linear coefficients is basically this. This is a form of optimization. There's no mystery here, guys. It's basically this stuff here. But, and that's another algorithms. These stuffs need to solve specific problems. When in the lasso we have a lot of features, insignificant features, okay? Like significant features. Like a lot of features insignificantly don't determine charge, don't have relationship, is insignificantly, and we need to clean up here. And for clean up here, we will sum a lambda with the quadratic coefficient. It's basically L2. Yeah, L2, okay? We have line here, and for solve it, we will take the lambda, okay? We have here the reg I less yi, the same formula of the cos, this formula of the cos, okay? Plus the lambda with the quadratic coefficients, okay? This basically is the formula of the last regression. And the last regression will clean, okay? Clean the insignificant points. Okay, I will clean with my hands, don't matter. Here. And it's clean for organize the features, no? But in the reads, what is the read solve? The reads is basically when have features more important than others, like big points, big guys here, big guys blue. We have big guys here. And the line will architecture, okay? Will architect for drop here. And we need to minimize these big points for normalization. It's basically normalization, okay? It's basically a normalization. And I will do a mistake here. The quadratic stuff is the ridge, okay? And the last is with the model. Yeah, I missed the stuff. Sorry, guys. Here is the model of the coefficients. The model of coefficients is basically the model, okay? The model like a vector. Here the rate is the quadratic, and the quadratic will not clean. Normalize the big points for normalize the points, okay? For don't have big points. So the formula is the cos function, the same cos function here, tag I less yi, the quadratic plus the lambda quadratic coefficients, okay? This lambda here, why we use lambda then gamma. The gamma reduced to, but lambda is more normally in the papers academics, okay? And the ElasticNet solve that two problems here. The ElasticNets have big coefficients and small coefficients too. And will clean and normalization. Okay, clean and normalization. We have big points here too. And a lot of insignificant points. The line will architect with the big points too, in the big points. And the formula of the ElasticNet for solve it is the lasso plus the ridge. Is the cos function. Okay, we have cos function here. Reg I less yi plus c plus the lasso, okay? Plus the lasso with the model plus the reads quadratic, okay? Have different indices here, is J and K indices. Linear regression is basically this. I try explain the formulas and stuffs. It's very I explain this final part in English. É muito chato, para falar a verdade. Essas fórmulas aqui são basicamente as fórmulas das equações. As respectivas fórmulas vão ser otimizadas pelo otimizador, que é basicamente quase igual uma média móvel exponencial. Uma média móvel exponencial remodelada para fazer aqui uma otimização em partes com o learning rate. O learning rate é basicamente o cérebro que vai armazenar todas as informações aqui dentro. The learning rate. vai armazenar tudo aqui dentro e vai tomar decisões melhores. Então, basicamente, a gente faz um gráfico com os coeficientes, que são os pontos, e uma linha. Essa linha vai comparar o ponto real com o ponto da linha, vai diminuir um do outro e vai fazer uma comparação real. E vai ajustar a linha para melhor especificar os dados. É basicamente isso que é regressão. A regressão dá para a gente o poder de fazer predições. No GitHub eu vou colocar para vocês dados do Kaggle, reais, e aplicações em Python. De como pegar isso e aplicar em Python, ok? É basicamente fazer predições de preço de casas, de sobrevivência do Titanic. Tem vários datasets lá da hora. E é basicamente isso. So guys, thank you for watching it. And in the next video I explain the decision trees. Okay? No, in the next video I explain logistic regression and later decision trees and bagging and a lot of stuff. So thank you for watching it.